Page 209, this is question 31, so it's another variation on our genetic crosses. And in the question it tells us this is what we call a sex-linked trait. Now, just to understand this, you need to remember that females are always XX and males are always XY in humans. So this is chromosome pair number 23. Now, the relevancy of this is the X chromosome, females have two of them. So we have X and then X. So any genes that are located on these chromosomes, there's one on each of the X chromosomes. However, if you compare that to the male, the X chromosome, the same as what you have in the female, but the Y chromosome is an awful lot shorter. So what that means is that sometimes if you have a gene located down here, there's no corresponding allele on the Y chromosome, whereas a female, they would have a gene located on this X chromosome, they would still have a corresponding gene on the other X chromosome. Males don't have that because the Y chromosome isn't as long. So this is the female, and this one here is the male. So it's just to be careful, if it says in the question that it's sex linked, we deal with it slightly differently. So we'll have a look at this question and we'll see how it works out. So question 31, it states, in humans, red-green colour blindness. So we're looking here at colour blindness. We'll keep our normal habits going. Just write down the topic first of all, or what you're actually focusing on. So it's colour blindness that we're looking at here. It says it's a sex-linked trait. A colourblind man and his wife have two sons. One of the sons is colourblind and the other is not. Look, we need to kind of make sure here that we're on top of things. So one of the sons is colourblind and the other is not. What is the genotype of the mother? Outline your reasoning. So we just need to be careful and get our index down. So there's different outcomes we can have here. There's different ways to actually carry out this question. Let's say first of all, we'll just run through our index here. So if it's a female, because they have an X and the Y chromosome, they could have capital N. So we'll call this one here normal vision. They could have capital N, small n. So that would be your heterozygous condition, in which case it would result in normal vision. And then they could be small n, which would be colorblind. Now, males, a little bit different to what we're used to seeing here. So a male's either going to have capital N dash, because remember, it can only be on the X chromosome, it's not on the Y, in which case they would have normal vision. Let's just put a little arrow here just to make it easier, because if not we can get confused. And then the other outcome that they could have is if they're lowercase n dash, and in that case then they would be colorblind. Now, in this question, what it asks is, or it tells us that a colorblind man and his wife have two sons. One of the sons is colorblind and the other is not. Okay, so if we look at the parents here, so it tells us in the question that we have a colorblind man and his wife have two sons. One of the sons is colorblind and the other is not. So a colorblind man and his wife have two sons. So if we look here, the first thing to look at here is the male. And we know that he is colorblind. And then we have the wife. So man and woman. We actually don't know if she's colorblind. It doesn't tell us in the question straight away, so we'll leave that blank for the second here. The male, it tells us that he's colorblind, so we know that he's N dash. What we do with these sex-linked traits is we put in if they're X and Y, so the male is obviously going to be XY. So we have XN Y dash. Okay, so that's what his genotype is going to be. And the female, we're not too sure yet, but we know that she must be X and X. Okay, we'll carry on with the question. We'll see how it works out here. So we have then our gametes, and so we split them again. So if you think about it, one of these X chromosomes goes into one gamete, the other X chromosome goes into a different gamete. The same thing with the males. So the X chromosome goes into one gamete, the Y chromosome goes into the other gamete. So with the male here, X lowercase n is one gamete, and then we have Y dash. That's our second gamete. Okay, so they're the two different possibilities here. So it's only the male that can pass on a Y chromosome. Therefore, it's only ever going to be the father that actually decides the sex of the child. All the eggs that are being passed on are kind of female, really, when you look at it that way. On the mother's side then, she's going to pass on an X and an X, and then we're just going to leave this kind of a little bit open because we can fill this in afterwards to make sure that it makes sense. We look then at our Punnett square. So our Punnett square here, we'll just put the X's and the Y's on the top. So we have X capital N, we have Y dash. And then on the side then, we're going to have X and then X. So we can carry on like with the question, we can fill in these afterwards, and it should make sense then at that stage. So really, what we're looking at here, this is going to be xn, and then it's going to be x something else. We'll add it in the sec. On this side here we have x lowercase n, and it's going to be x something else. And these ones here are going to be x something and then y dash. This is x something y dash. Now back to the question, what it tells us. One of the sons is colorblind and the other is not. So if you're trying to make the son colorblind here and the other son has normal vision, just think about it for a second. So if one of the sons is going to be colorblind, it needs to have this lowercase n and then our dash. So that means this here must be a lowercase n. So we have x lowercase n y dash, so that's your colorblind son, and then the son with normal vision must be x capital N y dash. Okay, we work backwards through the question, then we fill in all our capital N's and lowercase n's here. So this must be a capital N, this must be a lowercase n. So the first one here, we must have x lowercase n and x lowercase n coming together. So we have x lowercase n. Then we have an x lowercase n and then an x capital N. Back up to our gametes. So we have x lowercase n and then we have x capital N. So going back up here, x lowercase n, x capital N. This tells us that the woman doesn't actually have any issue with her sight herself, that she has normal vision, because she's a carrier for it, but she has the heterozygous condition herself. She's capital N lowercase n. So in terms of the question here, what is the genotype of the mother? The genotype of the mother, it must be that she is x capital N, x lowercase n, because she manages to produce two sons. So we can just put in here to see the cross. So when we work out the cross, you can see that she produces one son that's colorblind and one son that has normal vision. We then have part B of the question. If a future child of this couple is male, what is the chance that he will be colorblind? So the future chance, it tells us that it's male. So really with male, there's only two outcomes here, and it's a 50-50 chance. There's a 50-50 chance that it's either going to be colorblind or else it's going to have normal vision. But the whole thing with this question is understanding that the Y chromosome is shorter and that there's no corresponding allele on that Y chromosome to whatever gene is on the X. Just to be careful with that.